Hello everyone, and welcome to section 8.5, which is going to be all about variation functions. So there are two main types of variation. There's direct, which looks just like a line, y equals kx, and then indirect, which is going to look more like a reciprocal graph, y equals k over x. And in all of these cases, k is just called our constant of variation. It's just the number that tells us how they're actually related. We have two other types of variation that kind of stem off of these two. We have joint and combined. If a number varies jointly with two or more numbers, then you just know that it's a direct relationship more than once. And then if we have a combined relationship, we have that a number is going to vary directly with one or more number and then indirectly with one or more number. This will be important when we are actually solving these types of problems. In class, we'll look at how to know if it's, joint, direct, indirect from a table as well as from a general equation. But for now, we're just going to look at how to solve these. So basically, we're going to write our general equation. We're going to substitute our values. We're going to solve for our constant of variation. And then we're going to use that to solve our new situation. So they're always going to tell me what type of variation I'm talking about, as well as one situation where I know both the x and the y value or whatever other variables I'm using at the same exact time. So I see inversely, so I'm going to write y equals k over x. I know at the same time I have y equals 15 and x equals 1/3. I'm going to solve for k. So I'm going to use this. If I wanted to plug in multiple numbers, I might want to write for myself y equals 5 over x. But I do know exactly, I want to know what happens when x is negative 10. So my y value when x equals negative 10 is negative 1/2. And that's my answer. Again, we'll identify we're looking at directly, and then this is my situation where I know both pieces. So directly I know that it looks like y equals kx, y equals 12 as x equals negative 3. Solve for k. And then find y when x equals 7. Plug in what I know, and I get my answer. Y varies jointly as x and z, so I've got joint variation, and I know y equals 12 when x equals 3 and z equals 8. So I have a situation that looks something like this, y equals kxz. So plug in what I know. If I divide both sides by 24, I've got k equals 1/2. So I'm going to find out what I get for y when x equals 10 and z equals 5, using the k value I just found. Half of 50 gets me 25. Once you have your equation set up based on what they're trying to get you to look at, it's fairly smooth from there. Here I have f varying directly as g, so f varies directly as g, but also inversely as h. So anything that we're varying inversely with, I know that's going to be in the denominator. Find g when f equals 6 and h equals negative 5, so that's not the piece where I have all of my variables defined, but this one is, so I'm going to use that to find my k. So g equals 20, h equals 3, and f equals 5. We're going to solve for k. We get a k value of 3/4. Now I can use that to figure out what g is when f equals 6 and h equals -5. So f equals 6. My k value I just found is 3/4. And h is -5 in this situation. Multiply both sides by -5. Divide by 3/4 or multiply by 4/3. And I get that my g equals -40. So in class we'll look at maybe one or two more of these, but also look at how to determine what kind of variation you have based off of a table, as well as based off of just a random equation they might give me. I'll see you then.